So, I've asked you to do these sums. The first thing was an addition. What's the most important thing with addition is that the decimal points are under one another. So what I have to do here is I have to put the decimal point of the new number under the other one, which means I'm going to have 47.92. Okay? And I'm going to add. And this is right. I know this is right because here this number is 119. This is my tens number and it's under my 40. Okay? My 9 is under my 7. My tenths are under my tenths. And here my hundredths, there are no hundredths here, but that's just a 0 there. So I can't do anything until I've set the whole thing up right. Most important thing here, decimal points are under one another. If the decimal points are under one another, everything else sorts itself out after that. So now we just start always with addition and subtraction and multiplication. We always start from the right-hand side. We always start addition, subtraction and multiplication from this side of the sum. And the only one that we start on the left-hand side is division. So there's actually a 0 there, so let's put it in. 2 plus 0 is 2. 9 plus 7 is 16. We put down the 6 and we carry over the 16 part. The 1 that is a 10 moves over to the one that's 10 times bigger, and that would be in this column. 9 and 1 is 10, plus 7 is 17. 7 goes down here, the 1 goes up there. Before we do that one, make sure you put the decimal point in the right place. And then we've got 4, 5, 6 here and 1 there. So the answer to that sum is simply 167.72. That was nice and easy. 1 point for the correct answer. Then we have a subtraction. 124.1 minus 67.83. The smallest number is always written at the bottom and the largest number is always written at the top. We don't have anything up here, so we'd better put in our decimal 0. And we can see that in this sum there's going to be a lot of numbers that we're not going to be able to subtract. So we're going to have to borrow from the number that is a factor 10 bigger. This number here is 100th. This number here is a tenth. So this number is a 10 times factor higher than this number. Can we take 3 away from 0? No, we can't, so we need to borrow 10. This number now turns into a 0 because we've borrowed it, and we put it up here. We now have 10 minus 3. 10 minus 3 we can do, that's nice and easy, that's 7. Okay, now we have 0 minus 8. I can't take away 8 if I don't have anything to take away with. So I have to borrow 10 from here, that turns this one into a 3, and I now get the number 10 up here. 10 minus 8 is 2. Now I have to 3 and I need to take away 7. I can't do that. I can't take 7 away from 3. I don't have enough. So I have to borrow 1 again. That turns this one into a 1. And I borrowed 10, so that gives me a new number, 13. 13 minus 7 is nice and easy. That's 6. 1 minus 6, I can't do that. This number down here is much bigger. I have to have a bigger number. So I have to borrow the 10 again. 11 minus 6 is 5. Now I did an awful lot of borrowing in this one. So I would never quit here. It's very, very easy to make a simple mistake. So if you want to make sure that you've done a subtraction like this correctly, what you do is you add these two bottom numbers up and check that you get the top number. Because addition is much easier than subtraction. So let's do a quick check here. Let's add these two numbers. 7 and 3 is 10. 8, 10, 11. 7 and 7 is 14. Decimal point in the same place. 11 plus 1 is 12. So the top number should say 124.1, which it does. So this is my little check. That's a good thing to do when you've got a decimal subtraction with a lot of borrowing. So always add those last two numbers and check you get back to the original. Okay, that was the addition and subtraction finished. They all started from the right-hand side, notice. Now we're going to do a division. Division is the only one, mathematically, that we never start from the right-hand side. Division always starts from the left-hand side. Always. So our first question is, can 4 go into 12? Yes, it can, 3 times. Are there any left over? And what we're trying to think of here, what I usually say is, sweeties on the top and children on the bottom. Or grown-ups, I like sweets as well. If you've got 12 sweets and 4 children to split them between, how many sweets does each child get? They get 3 each. Every child gets 3 sweets each. Okay? Now we've finished that number, we've got a new number. Put the decimal point in the same place before you do the division. 4 into 8 goes how many times? 2. We've got 8 sweets and 4 people, everybody gets 2 sweets each. So that one's nice and simple. You get the answer 3.2. The next one is a little bit trickier. We now have 121.3 divided by 3. So again, we have sweets on the top, people on the bottom. We have 12 sweets and 3 people. How many sweets does everybody get each? 4. Are there any sweets left over? No, everybody got 4 each. Now we have 1 sweet and 3 people, and we can't suck on each other's sweets, can we, and have a third each? Disgusting. So how many sweets do we get? Nobody gets any sweets, so it's important that you put in the 0 here. Nobody gets a sweet, so it's a 0, but that sweet is left over and moves over to the next number. We now have a new number here. What's our number? 13. If we have 3 people and 13 sweets, how many does everybody get? They get 4 each, and there's 1 left over again. What do we do with this one? This one, actually, there's a decimal 0 there. So we now have 3 sweets and 10 people. Everybody would get 3 sweets, and there'd be 1 left over again. And we'd go on and on and on forever, because it would be 3s into 10, 3s into 10, goes 3 times. So what do we do in maths terms when we get 1 left over, like this? We call it a recurring number. It's not going to be 3, it's going to be 3, 3, 3, 3, 3, 3. So you can write it like this, 40.43 ... 3, 3, 3, like that. Or the maths way of writing it is just to put a dot on top of that 3, and it means it goes on and on forever. Okay? It's called a recurring number when it goes over and over again. So that's that one. And now we finished division, and they were the only ones that we did on the left-hand side, and division must always start from the left-hand side. And now we're going back to multiplication, which is another right-hand side one. And we have 1.3 times 0.7. What you actually do with multiplication is ignore the decimal points totally in the multiplication. So pretend that you're multiplying 13 by 7. Okay? 13 by 7 is really easy. 7 3s are 21. Carry over the 2. 7 1s are 7 plus 2 is 9. I have a little imaginary line up here which I call my addition line. I do it afterwards. I think you usually put yours down there. But I like to have it above the number that I'm going to add it to later. So, okay, so 13 times 7 is absolutely 91. But my question was 1.3 times 0.7. What do? I have the answer 91, but because I had 2 numbers after the decimal point in my question, I put the decimal point back 2 places in my answer. So instead of it being here as it is in 91, it has to move 2 places backwards. So it should go here. So the answer to 1.3 times 0.7 is 0.91. So there we go. 5 quick sums of plus, minus, division, multiplication.